Hey everybody, it's Robot here from Vespa Motorsport and ScooterWest.com. So maybe you have a Vespa ET4 or an LX, or pretty much most other Vespa and Piaggio products that are 125 and larger engines that are kind of run to modern days. They all have a similar charging system called the three-phase charging system. And I'll get more into the details of that. I'm not going to go into all the technical details, but I'm going to show you specifically how to diagnose if you have a faulty voltage regulator, faulty wiring, or a faulty stator plate, which is the magneto that has the coils that generate the power. This customer came in with his ET4. He's had it for a very long time. He went out and got another battery. He says, son of a gun, the battery just went dead again. The charging system, there's no light on the dash. There are some scooters that do have a voltmeter or a light. Maybe you don't know what those volts mean. I'm going to try to cover it in layman's terms, just simple terms on how to diagnose a charging problem with your scooter. It's going to be very simplistic. There's some much more advanced tests. Here at my shop, I have oscilloscopes, all sorts of fancy tools. When you understand those tools, electrical theory, it definitely helps you out. But I want to show just the basic mechanic, home mechanic, how to do some basic tests to figure out what you need. You wouldn't believe how often people call ScooterWest.com and they got an electrical problem. And I just tell you, no returns on electrical parts just because there's the potential to burn them up if you have problems or you don't know what you're doing. Not to pick on somebody. There's a lot of nuances to understanding electrical and electrical theory to get to the point where you really understand it. But let's get right into it. First of all, you're going to need one very, very important tool. You're going to need a multimeter. It doesn't need to be a fluke one like this. The $4 Harbor Freight one or whatever, the one they give you free, it's a piece of junk, but it probably would do everything you need to do all the tests that we're going to do. And I'll tell you when I'm in volts or ohms and what I'm reading and what I'm looking for. So first of all, before you start this kind of check, I would charge the battery all the way up. Make sure you have a good battery. Usually the telltales of your charging problem is the bike dies out, runs out of power and won't start up again one day, or you're riding along, it loses ignition on a long ride, something like that, or it's just not charging all that well, so the battery's going dead all the time. You're charging it with a battery tender. So I recommend having some type of battery charger, like a battery tender, the Optimate or the Nuoco chargers. You can look at my old videos on how to do that. But let's get right to the program. So we're going to get right access to the battery. So on a Vespa ET4 or LX, the battery is located underneath the seat. Primavera Sprints, GTSs, GT200s is located under the floorboard. The number one thing you need to check for is tight battery terminals that are corrosion free. If there's corrosion, like that white fluffy or the kind of green corrosion stuff, I would suggest cleaning these terminals off. Those can cause a lot of problems. I'm sure people have needlessly replaced batteries, regulators, electrical parts, and so on, when diagnosing why their scooter's not keeping the battery charged. So you need to have your voltmeter with you. We're going to set your multimeter 2 volts. A multimeter actually reads different things: volts, amps, resistance, continuity. And I'm setting it to DC volts. So every meter is a little different. If it's a manual ranging meter, you'll see one that says maybe 20 V DC, or it might have that line. That's maximum range would be like 20 volts DC. This is a more sophisticated meter that auto ranges, which essentially means it moves the decimal point around. And we're going to hook it up to this fully charged battery. So the positive terminal here, negative terminal right here. And that is a fully charged battery, 13.05 volts. The next test, while still holding the battery terminals, we're going to turn the ignition on and watch how much voltage drop it has. And if it was a bad battery, the volts would drop very rapidly. This is a good battery. I already know that. I tested with a fancy tester I have here at the shop. You can certainly bring a battery to a store like an interstate battery store. They'll be happy to test your battery once it's fully charged. Turn the ignition on, voltage drops. That's still a very good battery, but you could see it to continue dropping. Now we're going to start the scooter. And And with the fully charged battery, it's going to start, you know, pretty rapidly. But there's one thing I noticed. The voltage is not coming back up. It's very, very slowly coming up a little bit. Typical charging voltage, even at idle, should be, with the fully charged battery, should be well over 12.8 volts. But under 14.5 volts. Under 14.5, but over 12.8. Typically a scooter like this with a good charging system would be charging at like 13.8. So I definitely know the scooter's not charging. I'm going to turn the ignition off and check this out. The voltage is very, very close to the same, and it's dropping a little bit. So it's definitely charging a tiny bit. There's just a little bit of charging, but not much. Not enough to bring the battery up. You need to be charging at 13.5 to 14.5, somewhere in that range at some point to bring the battery charge up. It's definitely not doing that. I can do more sophisticated tests, like see how much current is going in or out of the battery, but we're not going to do that. We're just doing the volts. So the next thing you want to check is your fuses. This model, there's a pair of fuses. The one that protects the charging system is a 15 amp fuse. Make sure it's clean. The scooter wouldn't even start, and it wouldn't make any charging voltage if this fuse is blowing. But sometimes you have oxidized or dirty terminals or corrosion that's in the fuse holder, and that could be a problem. You may need to put a new fuse holder in there, cut the wires, but that looks fine, no problems there. That's also a perfect place if you need to check the current, but I'm not going to go into that. Next, we're going to get access to the voltage regulator. And on a Vespa ET4 or LX, that's located underneath the horn cover. On the GTS, it's under the glove box or under the floorboard. It's a much more difficult task to get to, that regulator, but the LX or ET4, let's just get right to the regulator, and we're going to get access to some of these wires here. So pull the badge off. Pull the horn cover off. You could also remove the whole entire glove box. I have videos on how to do that. And there's, you could already see we have access to some of the electrical components of your Vespa right here. So I'm going to get the horn out of the way, 8mm ratchet here. Disconnect the horn just so I can easily get access to the voltage regulator. So there's typically two fasteners that hold the voltage regulator in place. And the reason, even though the voltage regulator may be good, this is the perfect spot where you want to check all the wiring to troubleshoot a charging system. So also located right here is a ground wire. So is what a ground wire is it ties the negative of the battery to the frame. And typically, almost all modern vehicles are negative ground systems. I'm not going to go into the details of it, but we'll pull it away and make sure that ground is very clean. You can see the little corrosion on there. I don't think that's our issue today, but you might want to clean that terminal. Make sure you have a tight screw. You could see this regulator has 5 wires, and they typically have 5 wires. Some have 6. Sometimes, like the GTS, they have a pair of grounds and a pair of positives just for extra current carrying capability, because those are fuel injected bikes. They use a little bit more power. So but pretty much LXs, ET4s, they all have a very similar regulator between all the models. Even the fuel injected ones, they have a different part number for a regulator, but it's got a connector that's further down a pigtail. So next, we're going to go ahead and disconnect this regulator. And we're going to do some basic test of these colored wires. It's very universal to have the charging coils tied to these 3 yellows, and I'll do an illustration at the end of this video kind of explaining how this wiring works and what it does. But we're going to go ahead and get our multimeter and do a couple basic tests. So the first check we're going to do while it's still in DC volts is go between the ground, which is your black right here, and the red. And there we go. We see the battery voltage still present, and it measures nearly identical to what the battery voltage is at the battery. And I'd also suggest turning on the ignition, watch the voltage drop. If it drops more than a half volt more than what you see at the battery, there may be an issue with your wiring or the fuse holder. But the battery voltage is present, showing a full charge on there. The next test, we're going to set the meter to ohms, and it's a very, very low resistance. So you're going to be measuring milliohms or very low ohms. And if you have a manual ranging meter, you may set it to the 200 ohm range, not the kilo ohms. This is an auto ranging meter. Right now, with an open circuit, shows M for mega ohms. If I close this off, it is a very low, that's like 100 milliohms, 0.1 ohm, and that's just the resistance of the leads. And you should check the continuity, how your meter is. Some cheaper meters may measure 0.3 or 0.4, but we want to measure each of the coils on this regulator here. So these 3 yellow leads, they all lead to the stator plate that's located on the engine, and it's got a flywheel with magnets in it. Those magnets go over the coils and generate the power. So you're going to measure between each one of these in different combinations. So that looks right. It should be, typically the measurement you'll see is anywhere from 0.7 ohms all the way up to 1.5 ohms is the regular measurement. And then you're going to move the lead to another one. Something going on there. It's showing kilo ohms, or it may just show OL, which means open circuit, overload, open circuit. That's not normal. There's something going on. And then we'll measure between that one. Again, another set of coils that's open. So right now, I'm only getting the outer 2 that are showing a reading. But anything with this center one, there's a problem with the coil. And if I go there, there's a problem with that coil. So pretty much leads me to believe that there's a problem with the stator plate. If that all checked out right, I would probably, and the voltage is present at the regulator connector, and then I would suspect that you have a faulty voltage regulator. And most of the time, the voltage regulators, if they're not charging very strong, they may lose some of the diodes in here. There's a couple more tests you could do with the regulator in here as well. Just to definitely rule out that that it's a regulator problem. I'm going to set this to AC volts. So it's got a kind of sine wave right there. AC volts. If it's a manual ranging meter, I'd set the 200 volt range. And next we're going to start the scooter, and we'll probably see a similar issue where 8 volts, that's too low. 1.6 volts, that's too low. That's the only one, and it's getting drugged down so far, down to 10.6 volts. Well, normally you should see much higher voltages, and it should be even between each one of these measurements. I'm measuring the yellow leads. That's where the alternating current from your stator. So definitely kind of shows that there's something going on with this regulator. There's some more advanced tests where we could short it and measure each phase with a amp meter, but we're not going to do it. We already are fairly certain that it's the stator. All right, I'm going to draw up some illustrations. I'm going to do a little classroom session and show you the components that are typically in your charging system. So the components I'm going to show you are specific that will fit the 2001 Vespa ET4 all the way up to the 2009 Vespa LX. Once you went to the fuel injected models, they did change some of the components. So pretty much that range of scooters, addition to the Fly and the Typhoon with the liter motor, have the same motor as the ET4 LX. They're all going to use these same part number components. So you can find all these parts on scooterwest.com. I'll give you the part numbers, but I'm going to draw up the electrical schematics of the simplified charging system that's found on a Vespa. And it's pretty much the same across all Vespas, just different components. So first of all, we'll have the stator plate. And you saw that there's 3 yellow wires, and those yellow wires all go to the regulator, and they're all yellow. They all do the same function. In between this delta right here is coils that go in between there, and this is pretty bad. They're just like, that's like, if you look at a wiring diagram, you'll see some kind of coil, and it usually isn't a delta pattern. There's also the flywheel, which doesn't have an electrical symbol, but it's going to have typically several magnets all the way around it. And it's what it does is all these coils that are on the stator, I'll show you the part itself. When the magnet spins around, generates a magnetic field over these coils, and that's what generates the power. So yellow. And then the next component you have, it may be just a big block, and you'll have all those yellow wires go into this regulator. And in there are little symbols that look like diodes. I'm not very good at drawing these parts, but you probably don't need to really be concerned with the parts in there. But it's this type of power that's coming off 3 alternating current lines. They typically refer to it as 3-phase AC power. And all these sides of the diodes are all tied together, and all these sides are tied together, and that ends up with your plus and your minus. There's other electronics in there, that do some voltage regulating. And outside the regulator, you got the black and the red, and those go pretty much to the battery. So your plus and your minus, the black, and it's going to go through a fuse, typically on the red side. And if that fuse is blown, that's your problem. If you have a bad connection at your battery, that's a problem. So essentially these yellow wires go in between these diodes. They all tie in there. And those diodes is what you call as rectification of that 3-phase alternating current and turn it into a direct current that charges a battery with some other fancy electronic stuff in there as well. You also have connectors in between here. There could be faults in these connectors. So anytime you see corrosion on those parts, that could be a problem. So let me go again over the components of your charging system. You got the flywheel, you have the stator, you got the voltage regulator, you got a fuse, the main fuse. There's several fuses in a scooter, and then you got your 12-volt battery. All right, so let me show you the components themselves. The voltage regulator itself, if you did the resistance test on your stator, it measures good, and you see battery voltage at the regulator connector, and it's still not charging, then I would suspect you have a faulty voltage regulator. Part number on the voltage regulator is 486062. And if you notice, this regulator is much larger than the regulator that came out of the ET4. There's nothing wrong with the regulators in the ET4, but this is the better updated part that was found on the LX, and it's fully compatible with the ET4 as well. Pretty inexpensive part for a Vespa part. It's got the 5-pin connector there. So that's the voltage regulator, 486062. The next part would be the stator plate, and that's 828135, which is just a stator. Also available is the stator with the flywheel. And you ask maybe why you want to buy it with the flywheel. Sometimes the flywheel is damaged. Sometimes the magnets are physically broken. That could be a problem. So if you need the flywheel and stator for any 125, 150 carbureted Vespa ET4, LX, Fly, etc., 82572R, and it includes both the flywheel and the stator. So I'll show you the parts that are included. So first of all, there's your stator plate. Watch for the next video. I'm going to show how to replace the stator plate on this bike. I showed you those coils. Well, there's all your coils leading to, well, they're white here, but yellow, the 3 set of yellow wires. You got a pickup coil for your ignition system, and this goes to the oil pressure sensor. The next component is the flywheel. This is the much better quality flywheel over the original flywheel came on the ET4s. They kind of had plastic magnets in there and cheaper magnets. This has got the neodymium magnets, so it's a much better upgraded, more powerful flywheel. So, you know, that's one reason why it may be worth just upgrading the pair. You're going to end up with a better charging system if you buy the pair, because you're going to have the updated flywheel that was only used on the very late LXs and GT200. It's very similar flywheel. So that's part of the pickup. You're going to need a special tool to pull the flywheel off. I'll show you how that's done when I do the stator replacement. And you got to watch your fingers. The stator bolts to the engine, but there's very strong magnets. You can see it pulls that in there, and you know, obviously as it rotates, it generates the power. The last part when you're changing these out is this nut is supposed to be replaced every time. Part number on this nut is 436783 for the nut. So that's pretty much all the components. I hope I covered how to do some basic troubleshooting of the charging system on your Vespa or pretty much most other scooters. If your headlight comes on nice and bright and doesn't like look like a candle when it's starting normally, it probably has a charging system very similar to this, which is just a flywheel magneto 3-phase charging system. It's a very common system that's used in scooters that are typically 125cc all the way up to big motorcycles all have the same setup. Cars have a different setup. They call it an alternator because the regulation is done by changing the magnetism inside the alternator. But I'm not going to go into how those work, not used on the scooter. Thanks again for watching my lengthy video. I hope that gives you some tips on how to troubleshoot or better understand the charging system on your modern Vespa. So if you're looking to tackle a job such as replacing a stator plate or a regulator, or you need any other spare parts for your modern Vespa, check us out on web, scooterwest.com. And in addition to the spare parts, we have all the specialty tools needed, for instance, the flywheel puller available to remove the flywheel on most modern Vespas. They have different ones, pretty much use the same flywheel puller for all the smaller engines, and there's a larger one. So make sure it matches when you look it up on scooterwest.com. Thanks again for watching. We'll see you on the next one.